My name is Siyuan. I work at Google. So if you're in this session, I think you probably have heard of emulation versions. Emulation version, and so there's emulation version in Kubernetes now, and then there's the binary version. And if that's not confusing enough, we are also adding a new flag called min compat version. So today we're here to talk about how to navigate this new multi-version Kubernetes universe. So first things first, a little bit background. Why are we adding so many versions and why the added complexity? So it's for a safe upgrade. So traditionally, if you're a Kubernetes cluster admin, to upgrade a Kubernetes cluster, the control plane, you do it like you upgrade every component one by one by bumping the binary version. And after that one step, a lot of things are happening. So new features are turned on, new APIs are exposed, and then new data are persisted. So it's hard to know where, like in this case, the rollback is impossible. If you have to roll back, you're doing it at your own risk. So you don't know what would happen to the data, and if you roll it forward, what would happen to your cluster. So this is kind of a very scary monolithic process. So this crappy upgrade experience can cause a lot of maintenance cost, and also it can lead to a very big version skew in your cloud. So this is also not good for the Kubernetes ecosystem, and it blocks further progress. So that's why we need a safer upgrade. So the key improvement we're making is in this compatibility versions. So in this cap, we mainly introduce this more granular control over the versions when you upgrade your control plane components. And this is designed to make the upgrade safer by increasing the number of steps you can do during an upgrade. So there are basically two primary flags we have added in this cap. The first one is called emulated version. It's introduced in OIL 131, and it allows a component binary at version 1.n to emulate the capabilities to our prior release from n-1 to n-3. The capabilities we mainly referring to the APIs and features. And the second flag we just added in 135 is called min compatibility version. This controls the minimum version that a component can tolerate in terms of storage versions and other like validation rules and other stuff. So with these two flags, we can have a more granular control over the set of features you have, the APIs you're exposing, and then what the storage versions you're persisting to SCD, all bundled to a specific version number. And to help you understand this better, it's helpful to think of these two different versions as two different roles. The first emulated version, you can think of it as it defines what the server is. So it defines what this component is capable of, what it acts like in terms of features and APIs. And then the main compat version is about what this server understands about others in this cluster. So basically, it's about, it defines the minimum behavior that the cluster must tolerate. So with these two flags, we can have like different path for an upgrade, and it allows the the cluster administrators to move through a cloud upgrade with like smaller steps and safer steps. So in this example, we're breaking the upgrade into 3 different steps. So in the first step, you just upgrade your control plane binaries without changing the emulated version or main compat version. They stay at n-1. So after this step, you basically just changed the underlying binary without changing the behavior of the control plane. So after this step, you can run a bunch of tests and verifications to make sure that the new binary works. And then you can move on to, at this step, it's not too late to regret, because you can always roll back to the previous binary very easily, because nothing is really changed. And then after the verification, you can move on to the next step. So in this step, you bump your emulated version to n. So after this step, you are basically, so new features and new APIs introduced in this new release are ready to use. And it's just like what you had before compatibility version as an upgrade. So after this step, you have all the new capabilities of the new version. And then like if you have to do a rollback, it's not entirely impossible. And then if you are sure that there's no need to roll back anymore, you're pretty comfortable with the new release, then you can do an optional step to bump the main compatibility version. So that means you don't have any server in the control plane that is at the previous version anymore, and also you're pretty sure you don't need to roll back. Then you are just acknowledging that we're not going back anymore. So with this step, it can unlock some very interesting new features that were not available before. So this we'll cover later in this talk. So with these two different versions, we have a much more flexible upgrade experience. So we can have a rollbackable upgrade, and also we can have more diagnostics, because like for each smaller step, you can run different tests to verify that your cluster is safe after that step. And it's easier to isolate what is causing any failure. And then it also makes it possible to run skip level upgrade. So if you're upgrading from 132 to 135, previously you have to upgrade from 132 to 34, 33, 34, and 35, like in 3 different binaries. So now you can just upgrade your binary from 32 to 35, and then bump your emulated version in between, instead of having to upgrade the whole thing. And then there's also the possibility of the quote-unquote LTS. So it's an emulated long-term support. So if, say, for example, 134 is going to be out of support in this release, but you can still run 135 at emulated version, say 132. So you're kind of running 132, but it's a supported version. And also with the new main compat version, we can also have the possibility to opt in early for some new features by acknowledging that you don't need to roll back or backward compatible anymore. So how can we make this possible? So the implementation of this compatibility versions is a joint effort of the whole community. So the heavy lifting falls on everyone here. So as a contributor to the Kubernetes project, we need to do some changes to the development workflow we're doing. So first, we'll talk about how the contributing to Kubernetes is changed by the emulated version. So the key idea of emulated version is we can kind of go back in time, but we don't really have a time machine. So what we can do is just to rebuild the past from what we have in the code base. So that means we have to leave the paper trail of all the changes we're making. For new features, for features that are feature-gated, the normal feature-gate progression is not changed, so you still have to go from alpha, beta to GA. But at each step, when you are graduating to the next phase, you have to track when it's changed and how the default value is changed in this feature-gate spec list. So it's an append-only list, so don't change anything before. You just append your latest change to the end. And this will let the control plane components know at some previous emulated version what the default behavior should be for a feature and whether that can be like what stage it was at. And then because of this, and also for emulated version, we are supporting up to M-3. So that means we have this -3 version rule for code cleaning up. So if you're graduating a feature to GA, or if you're deprecating a feature gate, you need to now think about whether this could impact how the emulation version works. So the question to ask is, can this feature be toggled 3 versions back? If yes, then it's not time to clean up the code yet. So basically, any feature that has been that is graduating or deprecating can only be cleaned up after 3 versions. It's locked to default is true, and that means you keep the code to do the feature gate check, and also you have to keep all the tests related to this feature. And there are some testing lines you have to add in order to be able to toggle that after it's locked. And for alpha features, it doesn't fall into this category because we don't really emulate. We don't support emulating alpha features. So if your feature is alpha, you can feel free to change it or remove it anytime. And then for non-feature gate changes, for example, if you're changing how beta plus feature is implemented, or if you're changing some ungated code in Kubernetes core, You also need to think about how this change could affect the users at an emulated version. So the basic question to ask is, would your change be visible to the user at an n-3 in any way? So if it has a big impact on the user, some obvious visible impact on the user, then you should consider adding gate your change behind some lightweight feature gate. So this feature gate doesn't have to go through all the complex CAP process. It's just like a counting mechanism to track every change we have. And if your change doesn't have any user impact, like performance optimization or bug fixes, you don't have to go through the feature gate. So that is the changes that required by emulator version. So emulator version is more about recreating the past. And then this main compatibility version, mainly for contributor, it's more about a more forward-looking perspective. So when we change something in Kubernetes, there are a lot of things to consider. Whether a feature is mature, how mature a feature is. And also there are a lot of constraints around how your change might break the users in terms of compatibility. So what if we don't have to consider that anymore? So for example, if you are designing a self-driving car, you don't need the driver's seat anymore. So that's why we are adding this new main compatibility version. So basically what this does is if there's a way for the cluster administrator to stamp to confirm that there's no need for backward compatibility. For example, after you have upgraded your cluster, or if you're starting a new brand new cluster, there's no more backward compatibility concern anymore, and that will remove a lot of constraints related to features that require backward compatibility just for that reason. So we're adding a main compatibility version spec into a feature gate. So you can declare if your feature is mainly have to go through the alpha stage because of backward compatibility reason, not because of it's just a mature feature, then you can declare your new feature directly as beta, but default to be false. And then there's another entry in the feature spec that states that if your main compat version is the latest, then this feature can be default on. So that means users can opt into this feature early when there's no more backward compatibility concerns. So what kind of scenarios can this apply to? So for example, there are a lot of in cell features. So if we're adding new cell matching rule, currently we are kind of delaying it by one release because of backward compatibility concerns. So now we can adopt it, users can adopt the new cell rules one release earlier. And then also applies to other like CRD validation roles. And also if you're making some simple API changes. So you're pretty confident that this feature doesn't need to go through all the alpha, beta, GA stages. It's a pretty simple change. Then you can add it directly as beta, gated by main compat version, and that can accelerate your feature progression by one release. And this also benefits the users. They can opt into these features one release earlier. And just want to emphasize that this is not a shortcut for introducing new features. This is just for if your feature is only delayed by the compatibility reason artificially, not because it's like has to go through rigorous testing. So for more complex features, this doesn't really apply. Okay, and so to summarize, the introduction of compatibility versions is good for a more robust Kubernetes upgrade experience. And more specifically, the emulated version provides more granularity to your upgrade and also safer steps. And it brings a robust rollback capability. And for main compat version, it facilitates faster feature development and adoption, and when there's no concern for rollback or backward compatibility. And for details, we encourage our contributors to review these guidelines, especially the first one, and get yourself familiar with the new practice and think about whether your feature can benefit from the fast-track main compat version track. And this main compat version this compatibility version cap is just part of a broader effort to make Kubernetes upgrade safe. And we have other caps that are graduating or in progress to make the mixed version safer as well. And in the end, I want to express our special thanks to Han, who's the mastermind behind this cap, and without whom this wouldn't have been possible. And also I want to thank everyone who has directly worked on this cap or indirectly, everyone in the community has worked to make this capability, make the emulated version migration possible. Thank you all. Yes, Tim.
Does this mic work? Yeah. I'm thinking about how min compatibility version can relate to some of the new feature gate changes that went in this release.
Okay.
And so one of those that comes to mind is the feature gate dependencies. I don't think we put any validation around min compatibility version into that. It does check emulated versions across all.
That's right. Yeah, we probably need to think about it, how to add that.
Yeah. And then I was also wondering, so is min compatibility version just about like API server SKU, or does it also apply to like Node and other components?
It's about how it's mainly about how the data is stored, and min compat version affects how the storage version is picked. Mm-hmm. So if the node need to upgrade an API version, upgrade an API field, it also applies to Node. So if there's any need for min compile version in Node, we will need to consider adding the flag into Node as well.
Okay, need to think about that one more.
It's not wired up to the node, so
Yeah.
you can't change it there.
Yeah, you
Okay.
can't change it there yet. Yeah.
Okay.
Just to the first question, Tim, you asked, I think Siyuan specifically added the main compatibility version at the late stage of this release. So not many features can onboard it yet, but it's available for the next release. So people can start to try it out and then figure out what's need to be added in the next release, right?
Yeah, so at this point, we're not sure about what all the use cases that min compat version can help with. So we just listed a bunch of examples we think that are useful.
So the clients who are using like for 134 has a beta feature and 135 has a GA feature is V1 now, and there's a sidecar that was using the beta feature now changes the code to which was using V1 beta. One feature is now changed to use V1. Usually clients are just initializing one version of informers like just V1. They're throwing away the code. That version is no longer compatible with the latest, let's say, sidecar, CSI sidecar is no longer compatible with the older version of V1 beta 1. So when the emulated version changes, from the beta APIs could be enabled, and that sidecar is no longer compatible with the API server, actually. So we have kind of documented it as a limitation, but are there any plans to make it okay, are the clients expected to work with different versions to support this, or that's just up to the clients?
I think it's up to the clients. They can adopt this emulated version framework, but also we have flags in the control plane that in the API server that you can enable. It's called emulation backward compatible. So if you are if an beta API is enabled in your cluster, and you're emulating in 130, say 134, and you're dependent on the beta API, so then you migrate your client into V1, and then when you're upgrading your cluster to 135 using emulated version 134, you can turn on this flag so that it can serve V1 beta 1 at the same time along with V1. So there are workarounds around it.
Yeah, but the sidecars are generally coded to work with only one set of API, one version of APIs, not both at the same time. So they have to choose. So
yeah, so usually if a client need to dependent on newer APIs, they should do that after the full upgrade, not at emulated state.
okay.
So the approach makes sense to me with regards to one working version to the other. How does this accommodate bug fixes of new versions of older compatibility versions? So you have an older version, I produce, there's some bad bug in it. I want to remain compatible with that older version, but push a fix to it. How do I accommodate that?
So if it's a bug fix, it's usually not tied to the emulation version. So Jordan just added a fix for a bug in 134, and that one is not, it's a feature gated, but it's not the version for that feature gate is not 135. It's actually 1.0, so it can be backward. It applies to all the emulated versions.
Okay, thank you.
Yeah. Okay. All right, thank you.